Hey there, I'm Alejandro, and welcome back for day 128 of me doing the NeetCode 150 challenge. So today we're doing our very first LeetCode medium bit manipulation problem, and without further ado, let's get straight into it. Okay, today we get LeetCode medium problem 371, sum of two integers. Given two integers a and b, return the sum of the two integers without using the operators plus and minus. Okay, because otherwise, let's see, return a plus b, very nice and efficient solution, eh? Nice. Okay, so add two numbers. Oh boy. Okay. What was the hard part in binary? Was it adding two numbers or okay. You must not use plus or minus. Okay, so we'll have to it is bit manipulation. Okay. Oh, it's just I forgot how to do stuff with like a C adder and stuff. I guess you always remember like a bit at the beginning in case you overflow, right? Is that what's called a C adder? This is equal to 0. What happens when I XOR two bits? If it's 0 and 0, it stays 0. Oh wait. If I or here I can call this my carry. Oh yeah. Okay, so yeah, it's probably gonna be XOR, right? So 1 and 0 becomes 1. 0, 1 becomes 1. Okay, which is good. The only problem is, okay, so yeah, if you want to do 0 and 0, 0 XOR 0 is conveniently 0, right? 0 plus 0 is equal to 0. But 0 XOR 0, since they're the same, is 0. Now if you do 0 and 1, that becomes 1, which is exactly the expected behavior you like, right? Same thing for 0 here and a 1 here, right? Because they're different, so they map to 1, so it's as if though you were adding 1. Now if it's 1 and 1, it'll conveniently be 0. But then you want to remember, like, hey, you're going to carry a new unit to the next one, right? Now the only thing is, how do we go through the digits backwards, or the bits backwards? Or I guess we can convert them into binary and loop through everything backwards, right? We can use int, we can use whatever we want, right? We just cannot use plus and minus. Okay, so we can definitely do a comma b equals bin of a, and we'll just do from 2 onwards just to make our life convenient. Bin of b from 2 onwards, right? Let's just make our life convenient here. Okay. Carry is equal to 0. We need to add padding. Add padding. If length of a less than length of b, then here we'll say, oh, do I have my flux not here? Let's disable until sunrise. Okay, there we go. If length of a is less than length of b, we'll say length of b minus length of a 0. A equals this plus a, else b is equal to length of a minus b plus b. Okay. Print f string a equals b equals, and let's do it before as well, right? So that way we have padding, we have padding. Oh, I can't use the subtract operator. So maybe I do like while less than. Okay. Yeah. Here I can't be using plus and a and stuff. Also, what? Yeah, this needs to be. Parentheses needs to be here. Not here, not here, but here. But also this is not allowed, right? Because we're using minus and pluses. So yeah, I can't be adding padding this way. It's just I forget generally how binary adding is done, right? I know there's like I'm trying to think of it in terms of like, you know, the OR gates, the AND gates, the where they do it inside of circuits, and they have like a C adder. It's just I generally forgot how that works. Like I think it's called a ripple carry adder, right? But I generally forgot how those work. This is going to be an interesting problem to try to solve without remembering how ripple carry adders work. I mean, I guess it's a good opportunity to learn how they work, right? There's a difference when you have 0 because you had 2 zeros, or 0 because you had 2 ones, right? If you have 2 1, like I'm trying to think this in like terms of kindergarten math, right? Where it's like if you add 19 and like 43, then it's like okay, then like 9 plus 3 is equal to 12. So you put a 2 here, and then it's like you remember to put a 1 over here, right? And then sub these guys, and then do the same thing, and etc. right? That's what I'm trying to accomplish with this carry here. Where it's like if I have 1 0 0 1, then it's like this is very straightforward, right? But when there's 1 1s, I want to turn them into zeros, but I want to make sure that I carry the 1 over. And then if I have 1 1 1, it'll just be a 1, and I'll still have a carry of 1 as well. I could also just code this up into if statements. Right, for the because okay, if I'm gonna XOR with zeros, I'm gonna keep the first one, right? So here, if length of b is equals this, length of b is greater than length of a. But like here, okay, so do I do a while loop because I can't use a subtract sign? That's really annoying. Right? Or I can use like an index I and be like go through the minimum and then go through the maximum and keep appending zeros, right? Yeah, so I can't use the subtract operator even for subtracting the lengths. That's really annoying. Okay. Okay. Right, because here I could say you can reverse these, right? So less than length of A, and I is less than length of B. Loop invariant will be I. I can't do I plus or equal to 1. No, bro. Oh. Okay, so I need to do a for loop. I can't use a plus operator. Okay, for I in range, that is the minimum between length of A, length of B. Technically, I'm not using the plus operator, right? Or I guess I could use something like, okay, like, I don't know. It's like by that logic, I could do something like this, right? Return, I could do something like return sum of A comma B, right? Technically here I'm not using plus and minus operators, right? But this is just cheap, right? That's obviously not what they want. Technically valid solution. There you go. That's pretty funny. There we go. Okay. Yeah, so I don't know. Right, the point is that you're gonna have to iterate through the bits, right? And you want to keep track of both bits, right? Ugh. Okay, I mean, we could use something like string.join, right? If length of A is less than length of B, right? No, but I can't subtract two lengths. Oh my gosh. Okay, ironically, this is, oh my gosh, okay. Just like, it's like plus and minus between A and B, right? Like, if I want to get the lengths, it's like, you gotta tell me it's okay to put a minus sign, mate. I need to know the lengths. I need to put padding of zeros. I need to put zeros as padding. Needs to put some paddings. Or here we can say, max length is equal, length is equal to length of A, max of length of A, length of B. For in range length, a bit is equal to, if I greater than length of A, greater or equal to length of A, or A of I is less than length of A, else 0. B bit is equal to B of I, if I less than length of B, else 0. Okay, now we technically didn't use any plus or minuses here, right? Here I'm using a for loop, which feels kind of cheap because it's like, you're incrementing I every single time. So it's like you gotta give me something, right, that I can do. Like, I gotta have something I can do. I guess it's like technically, like, in a Boolean circuit, they really only have ands, ors, and just I don't know how to do a ripple carry adder. Right, you gotta have some way to look through the bits. At least in like a ripple carry adder, it's like which bit goes to where, so you can manipulate the wires however you like. I need to look at the individual bits, right? I have to. So I think using a for loop is okay. Because like at least in a Boolean circuit, like you have the wires linked to the bits. You can make them whatever you like. Here I don't have. I need to find a way to look at each single bit as if though it was one of my wires. So I need to be able to iterate over them. Okay, I think I'm chilling if I'm using a for loop. I think I'm chilling. I think that's allowed. Right? I mean, technically, it's don't use plus and minus. So like, technically something like this is valid, but like obviously that's not the intention, and obviously this is a bit manipulation problem, right? So I'm not gonna be that cheap, but I think we're okay with a for loop. If we use a for loop, I think we're okay. Okay, here we're backwardsing them. I don't know if we should. It just might make things easier to think about. We can also append to an array, right? As long as we just don't use plus and minus, but also don't do something like this. Like we should end up using bit manipulation as some part of the problem is basically it, right? And I'm gonna guess we're gonna use XORs. Now the only thing is when I XOR 1 and 1, it's really annoying. I guess what I could do is and I could XOR the carry with the and, or oh my gosh, okay. So the value should always be the XOR between carry, A bit, and B bit, right? Idea: treat this like kindergarten addition. You go from digits on the right, digits on the left, and always remembering your carry. So my carry is initially 0, right? Res equals this. We could do -1, -1, -1. Yeah, let's keep it this way. Okay, let's think about it. We're gonna have, initially we're gonna have a carry of 0, right? If we have a carry of 1, right, we're only gonna really have to carry both A and B. Or set, what if carry and B are set? Okay. So we want to do if any two. Right? Yeah. So here we'll do res append carry XOR A bit XOR B bit, right? Now we gotta remember the carry. If carry and A bit or carry and B bit or carry or A bit and B bit. Right, now if they're all 1, it's going to add up, it's going to become 1, which is good, and we'll still have a carry, which is good. Here I could be using logical ORs, but I want to use bit manipulation as much as possible. Right, this is one of those problems where it's just weird, right? I don't know what I can, what I cannot do, how I'm supposed to do this. I'm probably supposed to do this the way you're supposed to do a ripple carry adder. But even then, it's like you have a way to manipulate your bit wires, right? I need a way to iterate through my bits. Okay. Oh, here we'll just set, actually, we'll just set carry equals this. Actually, here we'll just do res append carry, whether it's 0 or 1. And here, return int of res backwards, comma 2. Does something like this work? No. Carry A bit, yeah. This needs to become an int. An int. String.join res. And I bet you this is backwards. String. Okay. String carry. Right? Is 6 3 backwards? Okay. Here I'm just gonna do res backwards because I think that's what it is. Okay, that's accepted. Let's submit. No. What? Oh, A is -1? That's a thing? Oh my gosh, okay. Okay, we just gotta remember the sign. Sign is negative. is negative equals handle negative. I can use times, right? Yeah. Res equals. Here we'll rename res to bits. Reversed bits. Here we'll say res. Int base 2. Also, if we did things in the other way, right? Okay. Wrong answer. Okay. Wrong answer. Output is null. Turn res. Okay. Nope. We need them reversed. Ah, yeah, because we need the zeros to be at the beginning. Yep. Reversed. Close. Yep. Bits is equal to reversed of reversed bits. We'll just do string.join bits, comma 2. Nice. Wait, we had a runtime error? Let me use this test case. Oh yeah, we need a handle that is negative. So here is negative. We'll have a less than 0 and b greater or equal to 0. Or greater or equal to 0 and b less than 0. Or actually, ooh. Oh, wait, no. You're gonna need, it's not multiplication. Oh my gosh. Okay, printf string a comma b equals. Is this what the 0b means? Wait. No. A comma b equals bin of a, bin of b. No, it's always 0b. So I do it. Wait, hold up. So we get 0b1 for the binary representation. Oh no. This is wait. This is not the one I want to see. Turn 1. But we get a negative sign. Holy crap. Okay. Is this when I do 2's complement? What's 2's complement? It's like flip all the bits and then add 1 or something. Okay. This is really annoying. Okay. Yeah, knowing how to do ripple carry adders would be kind of nice right now. Okay. This one we need to do 2's complement, right? But then how do I do the add 1? I just gotta, oh my gosh, go until the very end. I'll find the very first 0, otherwise I append the 0, right? Okay. Here we're gonna say def num to binary. Binary equals bin of num. If binary of 0 equals a negative sign. Okay, I can't use a negative operator, but I can look at it's being a sign. Okay. As long as I'm not using the operator, that's good. If it doesn't equal negative, then we'll just say turn binary from 2 onwards. We're chilling. Binary string. Otherwise, here's what we'll do. Range. Right, otherwise we'll do res that append left a1. Res, otherwise here we'll say or no, here we'll do if res of I equals 0, res of I equals 1, turn res, right? Otherwise, we'll just continue over to the next one, right? Until we find, or actually, since we're adding just 1, we'll say res of I is equal to 0. Carry on over to the next bit. Right? Otherwise, here at the end, yes, we'll do res dot append left. Okay. Apply 2's complement. Flip all the bits. And then add 1. Okay. 1 if bit equals 0, else 0, forbidden binary. Flipped all bits. Okay, we'll just put this first. Let's not make things confusing. Get rid of negative 0b prefix. That was changed to zeros and ones, but yeah, it still remains. Fine, range this. Now we're adding 1. Now add 1. Or if anything, I could have defined an add 1 function and just keep doing it, right? Res of append left. 1, in case we never return anything, and return res, right? Okay, so now we can say A comma B equals num2 binary string of A, num2 binary string of B. Oh gosh. Return string.join res. Return string.join res. This is not good, right? 1 and 1 is going to give me 2. So what do I really want to do? Do I want to add 1, make it 2, and then flip all the bits? Just doesn't make any sense. 2's complement, mates. Right, now the other ones are invalid. Why? Why are the other ones invalid now? Yeah, I have this. What? Why is this not working now? This is exactly what we had before. Oh, backwards. Let's reverse things. Let's keep things backwards. Okay, so this one is 2. Okay, let's think about it. We're given -1 and 1. It should sum to 0. Now, what is the 2's complement of -1, right? Well, I guess I'm supposed to treat. Maybe I do something like this. Res.append left a 1 because of 2's complement. I get something completely different, yeah. No, it's just that's what's supposed to represent the sign, right? Is 2's complement when you already have the sign thing? How do you use 2's complement? And is it flip all the bits then add 1, or add 1 and then flip all the bits? Res equals collections dot deck of bit for bit in binary. Still got 2, mate. It's even worse. The output is 2 on this one? What the heck? Just that then do I like complement it again or something? It's just I don't get it. I mean, technically, we know a way to solve this problem, which is just, return sum of A comma B. I don't like these restriction problems. Yeah. I guess I could look up something like 2's complement, right? Like, that should be fine. That should be more than fine. So I'm gonna eat a protein bar or a chewy bar. Let's grab one just because I haven't had breakfast this morning and I wanted to do a NeetCode problem out of the box, but needs a little bit of fuel. So let's get it. And then I really need my university hardware course knowledge to come back right now. I should think, right? Yeah, this is tricky. It's just like it's tricky just because it's like I can't really remember for the life of me how to do a ripple carry adder. I'm trying to think like with something like 2's complement, it doesn't make sense, right? Like I'm always gonna have this as positive. I'm always gonna think that whatever binary number I convert it into is 0 or more. How the heck do people use 2's complement for negative stuff? Even if I 2's complement back, it's just like, what the hell? Unless it's like I specifically exclude a digit. Right, let's think about the 2's complement of a number like 5. 5 is equal to what? 101? 1, 2, 4, yeah. 2's complement would then be something like 0, 1, 0, and then we add 1, which is 3. What information does that give me? Right, subtracting by 5 is not the same thing as adding 3 at all. Or if I added 1 and then subtracted, and then flipped, I'd have 0, 0, 1. I'd essentially turn 5 into 1. It's just... Oh my gosh. I might not even always make the number... I always make a number smaller with 2's complement. Is that kind of the idea? I always make a number smaller with 2's complement. Yeah, no hints. This is challenging. I'm tempted to just look at the definition of something like two's complement, right? Because like this is the point where it's like I'm trying to. It's not like I can't solve the problem, right? Like I can obviously solve the problem super duper easy, just some, right? Just don't know how ripple carry adder really works, right? Or like you have a C out basically. Just why I just realized how does like I know you're gonna have to involve two's complement, but I can't even comprehend why it's useful for addition. Well, it's just like you look at the sign bit and you have different behavior for subtracting than you do adding. How do you subtract numbers in kindergarten? I guess you were always given a bigger number up top than the smaller one. So I guess we can always have, the bigger number up top. Oh my gosh. Wait, I have to remember that Boolean circuits are able to do this. Like you don't even need complicated stuff. Should I keep the sign in all of them? Right, the C out tell me whether the number is negative or positive. Yeah, negative numbers are really annoying. Okay. Something like 1. Whether I add 1 makes it 2 and flip the bits and go back to 1, or flip the bit as 0 and I go to 1. So once 2's complement is 1. So I must somehow remember the fact that it's negative, right? I just must. Do I make every single binary number have a 0 in front of it or a 1 in front of it to represent the sign? Maybe 2's complement worked only because there's a sign aspect. Flip all the bits and then add 1. Okay. Pretty sure the add 1 step is at the end. Okay. Now that one's messed up. Binary 2 onwards. Let's fix case 1 real quickly. No, that's not the idea. It's the fact that we were doing things backwards so that way we can make it zeros for the padding aspect. Yeah. It's just mates. Okay. Yeah, you're gonna have to do things backwards. So now what I have is, okay, why is, let's just make sure. Equals B equals. So now the first bit represents the sign. If I put a 0 here, oh my gosh. Why is 1's 2's complement 1? This is crazy. I would flip the bit as well for the 2's complement. Yeah, I generally just don't know how to deal with the negative numbers. I mean, this is just specific knowledge, right? You just gotta know how to do a ripple carry adder, basically. It's just something I've forgotten. It's a good thing to review. Like, it's not a trivial thing to come up with. Even when I know what I need to think of, the fact that I forgot it it's hard to come up with again. Like, I can remember things like 2's complement and so on, yeah, but it doesn't make sense to me. Like, it's gonna feel like I have a positive number again. How am I gonna be adding that? Unless the operations for subtraction and addition are different. But I thought the point of something like 2's complement is that you could still, unless it's like I add these two and then it's like, I ignore the first bit, right? Really? Really, my dude? Actually, wait. Okay. Backwards. Okay, so we got these three cases working, but now let's look at other things. Yeah, let's look. -12 and -8 is supposed to be -20. Okay, so I need to be able to return negative numbers as well. What's the binary representation of 20? Okay, let me whip out something like my terminal. What is binary representation of -20? 10, 100. So let me take 2's complement. What if I do A equals 0, 0 equals -12, B equals -8 of A. Is this the 2's complement? What does the not sign do again? Not of B? Not of 1? Do you flip everything again? Not a 5? -6. Not a 3? What does not do? Is not 2's complement. But how do you use this? Not of A? Not of B? Not of 18? It's -19. Unless I do not of A, not of B. Ugh, 19. We're onto something here, boys. We're gonna cook. We're gonna cook. -1 and 1. Oh boy. This is hurting my head. Is not the 2's complement. But it doesn't mean I'm doing 2's complement wrong. What is not? Help not. Oh, bitwise not. It is not. So something like 5 has the bits 1, 0, 1. Right, which is like this. So it becomes 1, 0, 1, 0. But that should be -2, not -6. What is going on? Is not 2's complement. What is a bitwise not? Well, there's a weight in Python. I didn't know that. Bitwise not, eh? Bitwise not of 5 is -6. Bin of -6. Bin of 5. Bro. This has got to be the 2's complement stuff, right? Flip all the bits, 0, 0, 1. Okay, if anything, we don't have to understand how it works at all, right? What if we just trust that bitwise not really means like 2's complement? What's not of 1? 0? It's not. Okay, yeah. The fact that not of 1 is not 0 was not of 0. Mate, like, what the hell? Alright. Okay, I mean. Okay, we can abuse bitwise not in some way that might help us. Now, bitwise not of -1 is freaking 0. Bitwise not of 1 is -2. Like, this just makes perfect sense. How the heck am I going to use this information? Or bitwise not of 2. Is this just the negative -1? It is. For negative numbers, it's just the thing backwards. Okay, so just add 1, make it negative, basically. Yeah. Add 1, make it negative, which does sound like 2's complement. Basically, it's add 1 and flip all the bits. I see. Right, okay, so like here, it's add 1, 1, 1, 0, and flip all the bits. Dude, it's hurting with my brain. Okay. Right, if I do -12. Bro, how am I gonna... Oh, gosh. There's gotta be some way to abuse this, right? The fact that I turned it into 11, then I can complement it, right? Then this is 1 off. 1 off when I had 2 negative numbers. But this is 2. Yeah, end with like -1 so I can end with 0. I'm not sure what to do, quite honestly. Just this behavior is really weird to me. So you could +1 make it negative, right? It's like they're flipping all the bits and making this one a 1. Right, bin 5. Yeah, they're flipping all the bits and then setting the first one to a 1. Not p plus b is -1. It's crazy. Makes sense. There's a difference of 1. It's got to be 2's complement then. But how do I use it? I know I must use it. It gets worse with bigger numbers. Okay. should probably just go eat lunch and play some pickleball in the meantime. I can think about this. Right now I'm stuck. I might even just like, just pull up it's okay if I put, okay, like, you know what, like for now, we'll do this. We'll say, hey, return sum of A, comma B, right? Here we'll run this. And here we'll submit this. Right? So technically, this right here alone is a valid solution. Why? Because I didn't use plus or minus operators like they told me to. So I didn't violate any rules. Now obviously this is a bit manipulation problem inside of NeetCode and so on, blah, blah, blah. This is clearly not what they intended, but like, that way it's like, technically by the problem description, we have a solution. Just obviously this is not what is desired, but now it's just, I'm having a generally hard time remembering how to do ripple carry adder stuff and so on, and having two's complements. I'm thinking of maybe looking at a Wikipedia article to just educate us on how, like, ripple carry adder logic works, how two's complement works, and so on. And then once we understand that, it's like, okay, we can try to code up a solution, right? And I won't feel as guilty just because it's like, we technically found a solution that doesn't violate the constraints of the problem, even though it's like, clearly we're meant to solve this via bit manipulation inside of a NeetCode. And if I look at something like that, it's like I'm really looking at something that's core to, like, computers, computer science or computer hardware, right? Just like being able to add two binary numbers together. It's just like how to do it with a Boolean circuit and with logical gates and so on. So, and I kind of want to remind myself of that, and like I can use this problem as an opportunity to do that. And I think, like, with these things, it's like I don't consider myself, having failed the challenge. Like, it'll be the first time that I look something up, but it's like I can keep also trying to, like, trying to figure out, like, trying to essentially decode how I can use two's complement to essentially solve the problem myself. It's just that everything kind of seems a little bit off, right? Like, how do you add 4 and -4 and make it come to 0? Right? If I take the complement of -4, I do 3 plus 4, I make it 7. Complement of 7 is just not even close to 0, and so on. It's just like I don't remember how to abuse the semantics of two's complement, adding two numbers and so on. So honestly, yeah, I might have to look up at a Wikipedia article and so on. But for now, it's already getting late, so I'm gonna get my lunch and I'm gonna play a bit of pickleball, and I'll come back. I'm recording this on a Saturday, so I know it's not relevant to the NeetCode 150, but that way it's like I can be, in top shape for the contest today and everything and so on. So yeah, so like, yeah, obviously I'm releasing this video not on a Saturday, but this is like, after day 200 of the daily NeetCode challenge. Like, I'm pre-recording these videos, and it is a Saturday, so I'll take a little break. We made some good progress on this problem. We're like about an hour and 10 minutes in, and yeah, I think it'll be okay if I choose to look up, like, some Wikipedia article or something to just kind of remind myself, or I might even just look at a YouTube video in the meantime to, like, kind of remind myself how to do ripple carry summation and subtraction, or, like, remember how two's complement works and so on. If I look at some YouTube videos, I'll show the ones that I looked at when I come back. But for now, I'll take a little bit of a break. But for you guys, I will be right back in literally just 1 second. Okay, hey there, I'm back. I'm coming back late. It's past midnight right now, but my brain wants me to finish this problem before I go to bed today, or at least, like, spend another hour right before I go to bed. I was able to do today's daily and do the weekly contest, which was a good one because it's the very first time that I ever got 3 out of 4 on a contest, albeit a little bit cheesed, a little bit, but nevertheless got a 3 out of 4, which is pretty nice. But that's besides the point. So right after this, right after I paused the video, I did end up watching 2 videos. One of them, I forgot the channel name. It was basically they just showed you what XOR is, AND is, and so on, blah blah blah, but also what a half adder is, as well as a full adder. But they didn't seem very useful in that they seem to only work for positive numbers. And then I watched a video by the organic chemistry tutor it's like 24 minutes long and so on, where he covers two's complement and so on. But honestly, that video confused me a little bit because, like, sometimes he'd ignore the extra one, but sometimes he'd use it and so on. It was like, when do you use it, when do you ignore it, and so on. He seemed very, very like weird and inconvenient. And it's like one is supposed to like represent signed versus unsigned, but in Python, I don't know if it does that. Also, one thing I learned is, okay, here I'll open my terminal, although, okay, this is from the contest. That something like not 3 is not representation, but really 2's complement would be something like this, right? Well, the point is, like, if you want to get the 2's complement of a number like 3, it becomes -3, right? So it's the inverse of the binary bits, but then you add 1. Obviously, we're not allowed to use the plus operator, but we think we already have logic for adding 1, right? Now add 1. Right, something like this. Anyways, so yeah, so we can have some logic for adding 1. Yeah. Yeah. Yeah, there's no easy way to do it, right? You can't really... Okay. One thing I do have is a Geeks for Geeks article. I haven't read this yet, but it is quite lengthy, and I was like, okay, it has a lot of golden information. And the reason I started the recording is like, okay, if I'm gonna read this, I might as well read it while I'm recording, so in case I get any ideas, I might as well have them on video. I'll move to there, and there we go. Okay. All right, there are 3 different ways to represent a signed integer article: a signed bit, B 1's complement, and C 2's complement. Okay. Let's try to understand how these methods are derived and why 2's complement is preferred over others. As we know that data are stored in bits, how can we store signed integer in the memory? To solve this problem, we will first develop a naive solution and then iterate it. Okay, signed bit. When trying to store an integer, it seems obvious to reserve the leftmost bit for sign and use remaining bits to actually store the values. Is this not what store complement? Okay. For example, in a 4-bit system, the first bit from left will be reserved for sign. 3 bits will be used to store the values. Okay, but here they're assuming that they're in a 4-bit system, which makes me kind of uncomfortable. Although, if anything, here we have a constraint on the numbers, right? So what, here we'll do import math.log of 1000. Okay, so 2 to the 7, no, that doesn't work. Math.log base 2 maybe? Alright, 2 to the 10. Yeah, if anything, we can even make it 11-bit system just to be safe and so on. Yeah, where the first number represents the sign, right? So we could have an 11-bit system and do things. Now, the only thing I don't want to do is like use the plus or minus operators, right? That's the only thing. When trying to use, okay, the other 3 bits will be used to store the value. Similarly, in an 8-bit system, first bit from left will be used for sign, and remaining 7 will be used for values. Okay. Binary representation, decimal value. What is senior number? Okay, I don't understand. Okay, yeah, the 0, 1, 2. Yeah, this is, okay, -0, sure. Makes sense. By using this approach, we are successfully able to represent signed integer, but when we analyze it more carefully, we observe drawbacks. 2 representations of 0 in a 4-bit system, we should be able to store 1624 values, but +1 and +7 to what are remaining 2 values? That means what representation for +0, -0, but so what? So might be very frustrating to first check if value is +0 and then to check if it is -0. Okay, I see. For a circuit, okay, sure. Send extension doesn't work for negative numbers. Gangnam style video overflowed. No way, that's actually kind of funny. So the max, so that means over 4 billion views was too much. That's actually pretty funny. Oh, that's cool. So it is equally important that our representation system should be extendable easily, which is not possible with this representation system. Okay. Binary addition doesn't work. Oh, I see. Ooh, they're gonna cover binary addition. Okay, this is good. Why is the simple binary addition not working here? The reason is that the sign bit leftmost is not an ordinary bit and not part of it. So design the hardware circuitry to ignore the sign bit to perform addition and then append the sign bit. So this is no brief, yeah. So we have mapped negative numbers down up. If we change our mapping system to top down, from top down, then we will be getting following binary table. What does top down mean? So that this is -7. Okay, so the left bit is still reserved for sign. But yeah, so like it's the other direction. Okay, cool. How to get better representation of an integer in ones? Complement method, positive numbers. Are represented similar to sign integer method. And numbers are represented by using a NOT gate during hardware design. Yeah, okay, so I can use a NOT. That's very nice. That's very nice. Let's analyze this closely. We have two representations of 0, so that's why 2's complement is going to be nice. We plus 1 just to get rid of 0. Being there twice. Okay, signed extension doesn't work for negative numbers. Oh my gosh. Okay, signed extension. Signed extension. Oh, I see. Wait, that's a thing? If I do not to, bin to, int of 1101. Oh gosh, okay. Yeah, okay, Python does stuff weirdly. Okay, so it'll be negative of that. Wait, that's a 5. Or I guess is it because it goes in the reverse direction? It's 5, but it goes in the reverse direction. So 5 from 7 is -2. Okay, that's why that works. Okay. Why does Python just put a minus sign and then the binary representation of 2? That's insane to me. That is insane to me. Why do they do that? Help bin, please. Bro. Why does it just do negative like this? Python 3. It's so annoying. Okay, anyways. Right, because it's not going to understand when I make it add a 2's complement number. Okay, so I really just cannot rely on Python's built-ins. But, like, the point is that you're not expected to just not use something like a plus operator in the world. Okay. Alright. Binary addition works with modified rules. Okay. How did this one go away? Excuse me, what? Whoa. I guess the overflow just goes bye-bye? Like, great, okay. See, that's the one thing I didn't understand from the organic chemistry tutor. You just say bye-bye to the overflow one, but how do you know which one, when it's an overflow and when it's not overflow? It's like, I guess you define your system to be a certain amount of bits, and just anything that's above that is just like bye-bye. Is that what it is? I guess so, and that's why you get like into like 2 billion something wraps around to negative 2 billion something and so on, because it's just like there's a cap. There's just a cap. Could do something like that. We could indeed do something like that. Binary decimal. Oh, I see. Carry forward on your left. Most bit. I see. We like to add the carry back. Definitely, one's complement method is better than same bit. Result of having two representations 0, and our hack and binary addition gives clues to improve one's complement method. We have an extra representation of 0, while others, if we have a carry button leftmost bit, then we have to add +1 to the result. I see. Adding 1 bit to it, well, great. I can't use a plus sign, bro. Now we only have 1 representation. Okay. What happens to the carry? It just goes away? I guess before we needed to add 1, now we don't. So, okay, I guess what I'm missing is I'm supposed to fix a bit count, right? Now the thing is, how do I get Python to map things to their binary representation? Because I can't use the negative operator to turn things... Oh my gosh. It's just so annoying. Just Python just doesn't allow me to... Okay. What? Okay. Guess you ignore the carry there. Yeah, you just ignore the carry, okay. But somehow it works like magic anyways. I guess, oh, maybe if you keep it anyways, it would work because it's like for example, if you had negative 64, then having it would be plus 64, and then you have negative 128, which ends up being negative 64 anyways. Wait, so whether you include the carry or not, it actually doesn't even matter. Oh, maybe that's why. You can throw it out or not, or keep it. It doesn't matter math-wise. Okay. Now, the only thing is having Python understand what I mean when I have a negative thing. But it's just like, nah, bro, we have negative notation. Like, what the heck is this? What is that? What is that? I don't get it. Alright. That's very fun. What happens if I do like negative 2 XOR bro, this is about to blow my mind right now. What? Okay, so it's like they just represent stuff in this way. So when I get rid of the string, I can't do the stuff I want, but they still have it as like working operations. They just do their own little enhancements in the background. Okay, that's gonna be very, very fun because I still don't get to use the plus or minus separators. Binary decimal. What would be negative 2? 2 is this. The negative 2 would be 0, 1 plus 1, which is 1, 0. Whoa, no. Negative 2 would be 1, 1, 0. Oh my gosh. Okay, so 2 is 0, 1, 0. Negative 2 is 1, 1, 0. So when I do 2's complement, I get 0, 0, 1 plus 1.
0, 1, 0. When I do complement of 2's complement of this, I get 1, 0, 1 plus 1 is 1, 1, 0, which is indeed negative 2. So yes, I flip them both. So then when I do 1, 1, 1 XOR with 0, 1, 0, then I'd get 1, 0, 0. Which is negative something. Negative what? Let's take 2's complement. Plus 1 is negative 4. It's almost like... Oh, this is going to just confuse my brain to death right now. Okay. It's just fantastic. Arithmetic operators. This sounds useful. Yeah, not Python, bro. Integer's complement. Yeah. Adding binary numbers. Well, looking at this is cheating, right? We shouldn't look at this. Okay. It's just frustrating that Python stores negative numbers in this weird format. I guess the negative sign. If I do int of this, does it understand? Maybe we do 2's complement, but we just slap a minus sign instead of a 1. Yeah, this is fine.
Okay. I really do want to solve this problem before I go to bed. It's gonna haunt me if I don't solve it. Ugh. I'm so close to finishing all the mediums too. It's just this is giving me a blocker. For some reason. Maybe it's easier if I solve this in another language like C. What if we solve this in C or something? What if I do printf? Oh gosh. I can't use, oh gosh. Oh yeah, you gotta do modulo D like this. Oh my gosh. I'm not used to C. Semicolons. I forgot you can specify standard input, standard output. Here we'll do not A. 0. Yep. Oh, how do you do binary? Oh, how do you get the bits in C? Oh my gosh. I do not know how to get the binary representation of digits in C. Bin. Oh. Is bin a function? Is bin a function? Maybe this is a string? No. They don't know what by. How do you get the bits of a number in C? It's gonna be even worse. I guess I could manually get them. Or I could do like something like I could always get the last digit. So I could like end it with 1 and then shift. So like while a doesn't equal 0, I can do something. Oh, so this is gonna bother me. There we go. We'll do printf string of D int bit a and 1. That way we only get the last bit of 1, whether it's 0 or 1, right? Exactly. If it's a 1, it'll end with 1 is good. If it's 0, then it'll be 0. But then this is like the same thing as like, you know, a bunch of zeros. So everything will be ended with zeros. And then we can get rid of the last bit by shifting it by 1 until we eventually get to 0. A equals, I don't know if I can do shift equals. Here we'll just do printf string bit. And oh, there we go. What? Oh gosh. Is it right shift that I want then? Uh-oh. Uh-oh. Equals a divided by 2. Okay. Yeah, not quite. Although, maybe I'm getting everything in reversed. I'm getting the last bit. Oh yeah, I'm getting everything in reverse. Nice. Hey, hey, hey. Right. %d slash n. One. 1, 0. Case 3, it's -1. Just 1. 8, 4. 2, 1, this is 12. Interesting. Can I do a shift equals 1? Is that a thing? Or a shift? Okay, a is equal to a over 2, I guess. Yeah, it's weird. It's just gonna give me the representations this way, eh? Yeah, because, yeah. Yeah, okay, I'm not gonna pretend I know how to work with C. At least not for bit manipulation. A Python bit manipulation is another dimension of its own. Just why does it represent things this way? Why does it have to make life complicated? It probably uses 2's complement under the hood to just represent this in this awful way. I guess they do it just because it's like they don't want to have a fixed size. It's just Python. It's like it's Python being too good to solve my annoying edge case of you must not use plus and minus. The point is that it doesn't want to be fixed in any way, shape, or form. Oh gosh. Yeah, when the numbers are positive, life is easy. Life is being chilling. Okay, how about we think about this? There's something like -12. Okay. Okay, we have 1, 1, 0, 0. 1, 0, 0. If I 2's complement these guys, then I'll get 0, 0, 1, 1 plus 1 is 0, 0. And I'll get 0, 1, 1, 1 plus 1. The 2's complement of -8 is -8. What? Okay. I guess it's because it's a system that doesn't have the good enough padding yet.
I don't understand anything. Yeah, I guess it's 4 in the other direction though. Because 0, 0, 0 really reads. Wait. I guess it makes sense, right? If I've been 12, not 12, not 12. My guy. Okay. 0, 0, 1, 1. This becomes a 1 plus 1. Alright. This was 8. 1, 2, 4, 8. So now it becomes 1. 1, 1, 1 plus 1 is this. Alright, when I add these together, add. Okay. So I have 1 left over that I'll ignore otherwise. This is 1, 1, 0, 0. And what is the... This is... This is 1, 2, 4 plus 8 is 12. Brother. Okay. Negative 8 minus 12 equals 12. Yes. Great mathematics. Great mathematics. And then 1632. Whoa, wait. If I do 1, 1, 0, 1, 1, 0, then all of a sudden I can say bin int of negative 0b 0, 1, 1, 0, 0, comma 2. Bro. Oh my gosh. Bro, I thought I cooked here. Oh, I thought I cooked. I don't understand how Python does its negative stuff. It's so annoying. Because I need the int function to convert back from a string back to binary, mate. Come on. You ain't helping my dog. Because, yeah, if I have 1, 0, 1, 1, 0, 0, this is perfect. This is essentially 0 plus 0 plus, this is 0 times 2 to the 0 plus 0 times 2 to the 1 plus 1 times 2 to the 2 plus 1 2 to the 3 plus 0 times 2 to the 4 plus 1 times 2 to the times 2 to the 5. If this is negative 20, no, this is supposed to be negative 1. Yeah, that's negative 20. This guy, oh my gosh. Just the Python doesn't understand the 2's complement, mate. So frustrating. It's so frustrating. Because we can't make it add stuff this way. It's just Python's integers don't work this way. So then how did someone like NeetCode solve this problem, man? Python binary numbers just don't work. Just are not. They're not 2's complement, man. They just ain't. They just ain't. Like, this is the glorious thing we're looking for, but this is what Python gives to us, man. It's so ugly. It's so ugly. It's so ugly. Oh my gosh. Bro, why does it have to be this way? I actually don't know what to do then. Let's think. Yeah, XORing two numbers only works when it's 1, 0, 0, 1. Or 0, 0 is just with the 1, 1. It's annoying, right? You don't know if you got a 0 because you XORed two zeros or two ones. So XORing two numbers is just out of the question. Oh, man. Oh, man, oh, man, oh, man, oh, man, oh, man. Okay, honestly, technically, mate, I solved this without plus and minus operators, all right? Look, you want to see? You want to see? Return sum of A comma B, right? Look at this, all right? Do you see any plus minus operators? Because I don't. I don't see nothing. All I see is that this works, all right? And when I submit, I don't see one plus sign. I don't see one minus sign. I don't see myself having broken the rules of this problem, all right? By all technicality here, I solved the problem, all right? I don't see no plus signs or no minus signs. So if I really want to, I can look at the NeetCode solution because, well, partly just because it's like nearly 2 hours that we try to think of this. I watched 2 videos on bit stuff, read the whole Geeks for Geeks article, only to realize that Python just doesn't do stuff in 2's complement. So I'm so curious in terms of how NeetCode did it. And hey, technically we said that we solved this question in a non-violating manner. I didn't use plus and I didn't use minus. So I didn't do no such thing. I did no such thing. I never would use something like that. Pfft. Clearly, that's only for yeah. Yeah, I obviously have a lot of work that I don't really want to give up on here, but honestly, it's 1:30 a.m. I know it. I will not be able to sleep tonight or at least not sleep in peace. If I don't have this problem solved one way or another. It's already 1:30 a.m. And I know myself, which is I'm going to want to solve this LeetCode medium right afterwards as well, so I can say that I finished the LeetCode mediums. It's like, I know. It's like, come on. Technically I solve it, right? Only constraint is don't use plus and minus. I know another built-in. Easy, right? And it's not like we didn't try as well, right? Like we've actually tried. We've actually tried to come up with something coherent. It's just another lucky day. Okay, you know what? This is what I'm going to do. We're going to look at the NeetCode solution. We're going to understand what he did, and we're going to do it ourselves, and it's going to be fantastic, all right? We've technically given a hard, long attempt to this problem, and we've solved it in a way that is technically justified. Given two integers a and b, return the sum of the two integers without using the operators plus and minus. I didn't use any such operators. So by technicality, we've solved the problem. So we don't have to feel too guilty from learning here, because taking a little bit of an L here. All right. Sum of two integers, explanation. You have two integers, yeah, okay. Okay, he has a beautiful video on this, very cool. Brute force. Bruh, okay, well, kind of illegal, my guy. All right, that's not legal. All right, bit manipulation. Is it the, bit manipulation optimal? Okay, so there's two. Okay, everything's O of 1. Okay, press X out. Carry equals 0. Oh, okay, he goes up to 30. Oh, okay, you only need like a, is he doing, okay, let's read this. Mask, jeez, okay. Okay, he has a carry, he has a result, and he has a mask. What is this? 0, what is this value? Oh, max int, binary representation of this. Okay, sure. So how many dot count? 1. Is it 32? Okay, so there's 32 ones. Cool, my guy, cool. Alright. For I in range 32, a bit is equal to a. Oh, okay. He could just shift a by 1 every time. He just, okay, alright, he's trying to be a little bit saucy. Okay, yeah, basically get the ith bit from the right. At the beginning, you shift by nothing. At the next iteration, you'll shift by 1 digit. Yeah. Yeah. Okay. Wait. Okay, let me. We're doing some analysis here. Okay. Yeah, so he's getting it from the right? Because if we did 6 left shift 1, yeah, bin 12. Yeah, so this is adding a 0. Yeah, this is multiplying by 2. The other way is dividing by 2. Yeah, okay. Curve bit is equal to a bit, b bit, carry. Well, that seems awfully similar to what we've been doing earlier, eh? Over here. Carry a bit, b bit. Yeah, so he's just adding a singular bit together. Alright, this makes sense. Okay, well, my guy be illegally using some plus operators over here. Not quite legal. Okay, here he doesn't, so I'll cut him some slack. But okay, here he's just checking if this is greater or equal to 2. Okay, so this is equivalent to this statement over here, right? Because the point is essentially you want to know if you added 2 1s or more, right? Whether you added, if you added 3 1s, you'll just leave 1 1 behind and put a 1 in the next carry, or otherwise if you added 2 1s together only, then you'll leave out a 0, but you'll put a 1 in the next one, right? So as long as like 2 of them are 1s, then you want to have a carry of 1. So yeah, greater or equal to 2 and so on if their sum is 2 or 3, right? But you can just be like, okay, I want to see if there's at least 2, right? So if it's both carry and a bit, or both carry and b bit, or both carry and a bit, then in any of those cases I'll make it 1, right? That's kind of the point. Okay, so we can do this without plus signs. Cool. If cur bit, what's cur bit? What is this? What is this? What intonation? Is this how you do 2's complement? Well, let's test it. Let's do 12 XOR this guy. What incarnation just happened? Okay, I'm just not even gonna question it, mate.
If cur bit res or equal to 1 shifted by I. Makes sense. Actually, that makes a lot of sense. Wait, holy crap. Yeah, you just have a result. As you add the bits, instead of appending into an array, just set that bit. Okay. Okay, so this is the magic I'm missing, basically. What is going on here? What is this magic sauce? What is this magic sauce? This. There's no way this is 0. Okay, no. What? 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 Dun, 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 dun. Okay. What NeetCode did is kind of genius. We basically have this, right? So what is this? Mask and maxent. Carry is equal to A and B. Oh my gosh. Okay, I don't even want to understand what's going on. This makes a lot of sense, actually. We could even beat him to it and just say 12 instead of 32. Right? Or we can do 16 to make it whole. Or 11, I mean. The mask is weird. 7. What is this? 20. It will do next door to that. So he's doing overflowing tactics. So really for the use cases we have, we actually don't need this yet. Like something like this, okay, like for example, here if I copy this, if I do def, here we'll call this def NeetCode, right? We return self.NeetCode. This is actually going to work for the use cases here. Well, okay, obviously it's going to work with, yeah. What I'm saying is even if I comment this out, this is really only for the big ones. No. Jesus Christ, okay. This is so interesting. This will work with 12, right? Interesting. So you fix a bit system and you allow for overflows. Yeah, here we're using a 12-bit system where this is 2047. That's so cool. Yeah, I'm messing up the overflows here. That's really cool. Yeah, this would take me a while to figure out. I don't even, yeah, I understand what's going on obviously now. It's just, how does this, so he wants to go around. So basically if you're bigger than halfway, he's like, nope, go down to the negative side. He does this by XORing with the mask. XOR with 0xFFF. Then by doing the not.
Is it doing 2's complement? Because it does it by -1. Like, this is so insane to me. This is super clever. Then what's this? B does equal this. A and B. This is divide. This is multiply. 1. 1 should have 2. Yeah. This is multiply by 2. A, XOR B, and mask. Make these masks. Yeah, okay. This is, I guess this is just one of those where I just take the L, mate. Like, this is clever stuff, I'm not gonna lie. It's just like, because I'm trying to figure out, like, how do you come up with this? Because he's not even doing ripple carry adder stuff, he's just being a clever boy. Navdeep is a clever guy, my man. A pretty clever guy. He do be pretty clever, not gonna lie. I bet you the solution makes sense. It's just like, yeah, you know, maybe this is one of those cases where I watch his video, man. Like, yeah, this is my funny guy, eh? Even then, he's doing illegal stuff. He doesn't have to do plus signs. In fact, we should fix that up. He even calls it A bit, B bit, like I was. Curve bit is equal to this. Yeah, this is good. Yeah, no need for an if statement check there. And then here he can just do yeah, and now this is fine. Just what a clever boy. What a clever guy. Yeah, I'm gonna get rid of my abomination there. This is genius by NeetCode. Damn. And no plus signs inside, no my... Oh, yeah. No minus signs inside. Dang! Okay. What an effort, eh? What an effort. Red X-ray with mask. Oh!
I know why he's doing that. He's going the other order. Like how they were saying here in the Geeks for Geeks article. Oh my gosh. Dude, that is so smart. Where with two's complement, the one or even one's complement. Wait, where's the logic here? No, I want one's complement. Yes, where it's like 1000 instead of being -0, it's -7. As the other way around, right? Where it's like here, if I do 0x 7ff, yeah. So here, if I do 2048, 0x fff, 1100. Let me think here. So you're 1995 away. And then nodding that because of getting around the Python stuff. Dude, the guy is just built different. That is... Bro. That's... Dude, NeetCode is actually a genius, mate. He does that to do the reverse of the ordering for the negative numbers. And then that for the... Oh my gosh. Bro's a genius. Bro's actually a genius. Mate, I was not thinking of that. Oh my gosh. Only after reading up on everything. And even then, writing the solution, it took me a fat minute to like really actually digest what's going on here. Dude, that is clever. Wow. Actually, wow. That's it. And yeah, maybe I should make an effort to understand this solution because I bet you I'm gonna be going even harder, right? If A is less than or equal to max hands, else. Oh yeah, he does the magic sauce. Dude, the guy's actually like giga smart, bro. Okay, I guess it's like the same idea. Dude, that's actually so cool. Yeah, A. This is more how I would have done it though. This is gonna be wrong actually. Yep. Yeah, this you can't really do much though. Unless it's like res or equal per bit. Or
No, that does not make sense at all. This makes sense. Anyways, yeah, we can keep it as is. Like, this makes sense anyways. Go fetch the ith character. The ith significant bit. Yeah, I forgot that you could do shifting for looking at a specific bit. You don't have to deal with the strings themselves. That's okay. At least if there's one outcome I take from this problem is the fact that like you don't need to deal with the binary. You don't need to deal with bin at all. Like here, he doesn't even call bin once. You can use bit shifting. You can use bit shifting always to figure out a specific bit. That's a good trick. Okay. Honestly, I'm glad because that means I took at least one outcome out of this problem. This is just pure genius, and I don't know if I'll ever use it in another problem again because it's like, damn, that's smart. At least, like now, I'll just know for the rest of my life that you can essentially go to specific bit by just doing bit shifting. I don't know why that did not come to my mind at all. That did not come into my mind at all. Okay, well, that's it. You know, at least we were able to do the problem. So, nevertheless, as always in all my videos, I do a quick recap if I was able to solve the problem. So for this one, at the end of the day, by technicality, although pretty unfairly, we found a way to do this problem without using a plus or minus sign, which was by doing this, right? Obviously, under the hood, like, you know, they're probably using plus and minus signs, plus signs in order to do that, but something like this technically works. I didn't use plus or minus signs and so on. So by technicality, I did not, like, you know, break the rules of the problem, even though it's obviously probably not their intent. So I didn't technically fail the NeetCode 150 challenge, right? After that, I gave, you know, a big, hard, long problem, a big, long, hard shot at the problem, and ended up getting stuck and so on because I forgot how to do ripple carry adders, two's complement, and all that bit manipulation, juicy stuff when it comes to binary addition. At least with negative numbers, where I solved the problem for positive numbers, but I really had a hard time with negative numbers, and so I started looking at some YouTube videos by the organic chemistry tutor and another guy. We read this entire Geeks for Geeks article about two's complement during the video and so on. It was just a lot of trying, and eventually I ended up looking at NeetCode solution, since like technically we solved the problem that in a way that doesn't break the constraints of the problem, even though it's like obviously not what they wanted with the sum stuff, probably, you know. So I didn't feel too guilty at the end of the day. And oh my goodness, is this solution smart, especially this part over here. So one thing I learned, and one big takeaway that I learned from this problem that I'll know for the rest of my life for bit manipulation problems, is that you don't need to do bin on a number and then converting it back to integer so that you can get the specific binary digits. You can use bit shifting. It's something I'll just know. It's something like I knew what bit shifting is. It's just it never crossed my mind. Like, you know, if I want a specific bit, I can just use bit shifting. And that's a big goof by me, but it's something that now I know, and I'll just remember forever. So, you know, this problem is a W, not an L. So in that respect, I at least learned something, which is very cool. Okay, but otherwise, in terms of solving the problem without sum or anything else, the idea is to essentially just add binary digits together, right? And the point is this, right? If you have something like 0 and 0, they should, you know, obviously add up to 0. If you have something like 0 and 1, they should add up to 1. If you have something like 1 and 0, they should add up to 1, right? And so far in all of these cases, XOR will work. 0 XOR 0 is 0. 1 XOR 0 is 1. 0 XOR 1 is 1, right? Now the only problem is like something like 1, 1, if you really want like 2, right? And the point is that something like this, you'll essentially have 0, but you'll need to like remember that you have a 1 up here, right? If you think about kindergarten math, right, where you do 19 plus 3 here, right? Where maybe the plus sign is over here, right? Then essentially this becomes, it's like, okay, here it's like, okay, I'll put a 2 here, but then I'll overflow with a 1 up here, right? So the point is I'll remember a 1 here, and then I'll put like my 2 over here, right? And the answer is 22. 1 plus 1 is 22, right? This is kind of the same idea, where you have 1 plus 1, here you'll have a 0, but you'll remember a 1 up here, right? And so that's why in this problem we always have something called a carry, which is like essentially kind of like carrying, like in that kindergarten type of addition, right? And so, except that instead of base 10, 1 and base 2. But otherwise, it's the very same idea, right? Where here we overflow whenever a number is at 10. Here we overflow whenever a number gets to 2, right? So 1 is the maximum possible digit. 9 in base 10 is the maximum possible digit, right? But it's the very same concept. And so here, what the reason I do for I in range 12, NeetCode did 32, is because the numbers are up to 1,000, right? So if I do a math.log of 1,000 base 2, well, import math probably is smart. Here we'll get 9.9, right? Which means 2 to the 10 is sufficient enough. Now we want to handle negative numbers as well. So we really need 2,000 numbers worth of stuff. So 2 to the 11 actually cuts it, right? And the point is that here we'll handle negative numbers as well, right? The midpoint will be 0x7ff. Just because 2 to the 12 is actually 4,096, right? But that way it's like anything that's above 2,047, we'll consider it as our negative counterparts and so on. It's just the genius stuff that NeetCode did. It was but okay. Nevertheless, essentially the idea is this. What we're going to do is for n range 12, like these are the only bits we care about because we know that the numbers between negative 1,000 and 1,000, right? So 12 bits will be enough to encode absolutely everything, right? Because it'll be 4,000 worth of numbers. So it's definitely more than enough, right? We could probably get away with 11, right? Here we can probably do something like... Uh, 2047 divided by 2. Yeah, 1023. There should be 11. Okay. Maybe we do 0.5. Alright. 1024. Okay. Yeah, this might not cut it. So you know what? Let's just keep it to 12 because that way we won't deal with annoying little midpoint ways. Okay. Enough runtimes. There we go. Okay, we'll just leave it as is. That's fine, right? But with 12, we definitely have sufficiently enough. So here what we'll do is essentially we always want the least significant digit, right? Because we're going to add with that, right? For example, if we do something like, 1, 2, 3, plus, 9, 8, 7, or 7, 8, 9, then essentially, we're always going to add the last 2 digits first, right? The least significance first, right? And then this is like, oh, this will overflow, right? And then we'll have a 1 up over here, right? And then we'll keep going and so on. But the point is that we start with the least significant digit, right? Which is why we'll do a bit and b bit. We'll essentially take a and b values, right? And end them with the value 1. And what's nice is if we convert something like, a or b, right? Let's say that a is equal to 6. Then binary representation of 6 is what? Is 110. So essentially a is equal to 110, right? And with 110, if we end it with 1, essentially this is ending it with 011, which means that everything here that is not the last character, everything else is zeros. So essentially we'll have zeros everywhere except for the last bit. We'll look, okay, this 1 Is this a 1 as well? No, it's a 0, so this one will be 0, otherwise it would be a 1, right? So that way, essentially, we get the bit, which by ending with 1, we always get the very last bit inside of A, right? And then here we'll keep shifting, we'll keep dividing A and B by 2 by bit shifting it by 1 to the right, because that way, essentially, we'll get rid of the last digit every single time. So that way we can essentially loop through the last 12 digits of A and B, right? And if they happen to be 0, we'll always get 0. So that's how we can effectively, like, get that padding that we need and so on. This is actually a very clever way of doing stuff. In the future, I'm going to try to start doing manipulation problems without the bin function in Python, just to be a little bit better and understand this stuff a little bit more. But that's basically it. We just get the most significant bit here, least significant bit here, what I mean, sorry. Another way of doing it is the way that NeetCode did it, which is this is equal to, a shifted of I and 1 and 1, right? So let's see if something like this works. Actually, this is going to not work because this should be the other way, right? Shift to the right this many times. And 1, there we go. So something like this works as well. Well, the point is essentially we want to get, so whatever I is, at the beginning I is 0, right? So when we do shift A 0 bits to the right, essentially we'll do nothing and we'll end with 1, so we'll get, the rightmost bit of A, right? Then when I is 1, we'll shift by 1, which means we'll get the second last digit inside of A in terms of its binary representation, etc., 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 right? So we always get, the next least significant bit that we want, starting with the very first most, right? Then we'll always get the current bit. So essentially we want to add the 3 numbers together, right? Oh, we want to add, the 2 bits together, right? Kind of like we're doing in the kindergarten notation. Now, the only thing is that, think about it. If I want to add the 3 numbers together, I always want to do it with XOR, but I'll always remember what's in my carry. So here, if I have something like 1, 1 plus 0, 1, essentially here's what's going to happen, right? Here we'll have, 1 plus 1 is 2. So here it's like, okay, 0, and essentially we carry on over our carry over here, right? And then 1 plus 1 is 2. This becomes 0, and then we have a carry on over here, right? And this just becomes 1 over here, right? And that's kind of the idea. And so that's the new number, right? And so essentially 3 plus 2 is equal to 3 plus 1 is equal to 4. There we go. This is 3 plus 1 equals 4. And that's pretty much it, right? Now, if this was a 1 as well, then essentially we'd have 1, 1, 1 here, right? Which is the same thing. But this will overflow to a 1, and then we'll have a carry over here, right? Now, the thing to notice is that if I do 1 XOR with 1, that'll be 0. XOR with 1 is 1, right? So in either case, we can always just do XOR, because 1 and 1 will go to 0. 1, 1, 1 will go to 1. As long as we remember to do our carry, right? And so how do we know whether or not to do a carry? Well, if there were 2 or more 1s, right? Between A bit, B bit, right? So here's B bit, here's A bit, here's our carry, right? If 2 of them at least were 1s, then essentially we'll need to have a carry of 1 to the very next one. It's just that if there were 3 1s, then the value that was here will end up being a 1. If it was just 2 1s, then the value over here will end up being a 0, right? But we'll still have a carry in there because we had 2 1s, right? So the way we can check if there's 2 1s, we'll just say, okay, was it the case that both A and B bits were set? Or was it the case that both A bit and carry bit was set? Or was it the case that both B bit and carry bit was set? And we'll just do the bitwise OR of all of these. So carry will be 1 if any of the 2 of these true were together, were valid together as 1 at once, right? So that's essentially how we'll always be able to calculate the carry. Between the previous carry, which is initially 0, remember, at the beginning we have no carry. So between A bit, B bit, and carry at any point in time, we'll always just recalculate the carry that way, right? And so that way, for summation, we can always just do XOR of the 2 numbers, right? 0 XOR 0 is 0. 0 XOR 1 is a 1, which again is the same thing as if we were doing plus. Or 0, 1 XOR is 1. And then 1, 1 will become 0, but we'll set our carry to be a value 1 so that we can use it in the next one and so on and kind of do that kindergarten mappings, right? Then, instead of using an array like I was doing before, here it's very smart what we're doing. We have our current bit, and it's like, okay, we're setting the new current bit and so on. How about what we do is this. We'll set the ith
least significant bit of res to cur bit. There you go. All right, you start off with res equals 0, and so you'll keep setting the bit with current bit shifted by I, right? And at the very end, you'll just end up ignoring the carry, because, well, if you don't, you can choose to or not. It doesn't really matter. Here, if I do, well, here it might just because of the way that we did this logic and so on. But if you're doing 2's complement properly, it shouldn't matter, right? But the point is that you can ignore the carry if you really want to. Now, the magic sauce of this problem comes from this part over here, which essentially what NeetCode is doing is he's defining essentially numbers that are more than through the halfway point, right? So there's 4,096 numbers. Any number that's greater than 2047 will essentially go from, like negative 2048, negative 2047, all the way up to a -1, right? So he's defining the numbers as any number that's great. So you essentially have the numbers from 0 to 2047 are valid, and then from 2048 to 4096, those will represent the negative numbers from negative 2048 to -1, right? Now, what he's doing is actually extremely clever, where essentially binary addition doesn't work with signed bits, right? Where you just use the left bit as just the signed bit, right? It does work, however, when you flip the order from bottom up to top down, right? So here, what it means is like, okay, 1, 0, 0, 1 means negative, and 0, 0, 0 is value 0, right? Versus 1, 1, 1 is value 7. So 1 being negative, so here you have -7. Now, if you flip the order of things, it actually makes binary addition possible, right? So instead of 0, 0, 0 mapping to 0 as before, now it'll map to 7, and the 1 will still mean negative, right? And now 1, 1, 1 will be the one that actually maps to 0, right? And with 2's complement, things are a bit nicer because you won't have 2 repetitions of zeros and other things and so on. This is exactly what NeetCode is doing. He has the mask here, which is 4096, and by flipping all the bits, because essentially this is just a bunch of ones, right? He's flipping every bit inside of inside of res, right? Essentially, he's flipping every single bit inside of res, flipping them so that essentially he makes it the negative key. He basically, like, instead of having the sign bit representations as this, he flips all the bits so that he maps, like, the top down ordering instead of the bottom up ordering, to have the negative zeros mapped, like for example this to have mapped into 0 instead, and so on. And then from there apply the not operation to make it negative, and with the -1 and so on, which will work with 2's complement and so on. So what he's doing there is just absolutely genius, and it only makes sense to me now after I read this a Geeks for Geeks article and so on. But that is actually an extremely smart and clever step. And at the end, obviously, he just returns res. I don't know if I would have come up with that on my own. That is pretty dang smart. I think this is probably one of the hardest bin manipulation problems I've ever had to do, right? Obviously, we just return sum of A and B. Technically, yes, I didn't violate the question, but that's obviously not what they wanted me to do. So yeah, technically it's like, took a little bit of an L on this problem and so on, but at least I learned some new things, right? Especially just learning to just bit shift instead of using the bin function. That's definitely something I'm just gonna remember and carry with me in the future whenever I do bit manipulation problems. And so yeah, that's pretty much all. Hopefully that solution makes sense. I know I kind of breezed through it, but it's past 2 in the morning, so that's why my brain is not the sharpest right now at the moment. But one thing that we very much can do is now we can say that, hey, we have done this problem. We spent a long time struggling through this. This was, really great learning outcomes for me. So I really respect it in terms of that. Technically, we solved it without violating the questions and so on. So we didn't fail the NeetCode 150 challenge, although of course we did. Today's been a day of being cheeky. I did something cheeky on the weekly contest today. Did something cheeky here on this problem and so on. Today is a cheeky day for me. Yeah. It is what it is, I suppose. This was a fun one. A struggling one, but what I like is the fact that I learned stuff. So you know what? If anything, this will get my 2nd star ever. The only other star I've given, where was it? Was it Advanced Graphs? Yeah, this is the only star I've otherwise given, because I actually kind of like this problem too, just because I learned to do Kruscals and prims from scratch without ever having coded them up before. So that was a very fun experience for me in learning how to use disjoint sets and stuff like that. So that was very cool. And yeah, okay, this problem gets my 2nd star. I took a little bit of a nail, but by technicality, I didn't fail the challenge, and so that's very cool. And yeah, I learned something at least. So in my eyes, this was a dub. This was a W. Oh, and now we're at 100 out of 101 LeetCode medium solved. We are at 100. We're in the 3-digit categories for the LeetCode medium. That's actually pretty amazing. But yeah. What a problem, eh? What a problem. Took me a little bit of a bit, but it was a good challenge. So I'll at least leave it at that. But otherwise, that's pretty much it for this video. If you did find it useful and enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So till then, ciao, ciao, my friend. Bye-bye.